Welcome to this explainer brought to you by Forge College. So, today we're tackling something absolutely crucial. We're looking at the ultimate capstone blueprint for proving, without a shadow of a doubt, that your crypto backup actually works. We're talking key derivation and address verification. Let's get right into it.
So here's the scenario. You wrote down your seed phrase, you tucked it away perfectly safe in a sock drawer, but does it actually work? I mean, really work? Most people just kind of cross their fingers and hope for the best. But let's be real, hope is not a strategy. In the Web3 world, we need mathematical proof. We have to know for sure that if you lose your device, that little piece of paper is going to bring your exact addresses right back to life.
Okay, let's dive into this blueprint. Here's what we're covering. 1. The backup checkpoint. 2. Demystifying derivation paths. 3. The verification script. 4. Interpreting mismatches. And finally, 5. The final artifact.
Section 1. The backup checkpoint.
Right. So in our previous lesson, you went through a guided wallet creation, you secured your seed, and you even did a manual restore right there in the user interface. And hey, that's a fantastic start. But what we're doing today is moving from that kind of basic manual trust over to programmatic cryptographic certainty. Look, clicking around a UI to do a manual check, totally fine for a casual user. But true operational readiness, that requires way more rigor. We really need to convert that manual process into a rock-solid, repeatable, auditable script.
All right, moving on to Section 2, demystifying derivation paths.
Okay, before we write a single line of code, we really have to wrap our heads around how one single master seed safely and predictably branches out into multiple distinct keys. That specific route, we call that a derivation path. Think of your hierarchical deterministic wallet as this massive, sprawling tree. The derivation path is basically the map that tells the software exactly which branches to climb. It uses specific elements, like hardened segments and index components, to just keep the whole shebang strictly organized.
And this brilliantly illustrates the concept. Imagine your seed phrase is the master key to a giant skyscraper. It gets you in the front door, right? But the derivation path, that's the turn-by-turn directions to find the exact safe you want to open. You could hold that master key all day, but without the specific instructions to, say, room 44, floor 60, index 0, you're literally going to be wandering those hallways forever. You absolutely need both of these pieces to actually access your funds.
Take a look at these specific paths. For Ethereum, you'll see the standard path starting with 44 and 60. But for modern Bitcoin SegWit, it starts with 84. An explicit path selection is absolutely crucial here because it prevents some really dangerous assumptions. If you just jump to a brand new wallet software, it might default to a completely different path entirely, and boom, you're left staring at a zero balance. No one wants that.
Which brings us to Section 3, the verification script. Okay, it is time to roll up our sleeves and actually build this verification machine. You can use a language like Node.js or Python, whatever you prefer. The logic here is wonderfully simple. Step 1, you input both your original and restored seeds. Step 2, you command the script to derive keys using those explicit paths we just talked about. And Step 3, assert equality. Basically, do the outputs match? Building and proving this with code perfectly mirrors the kind of hands-on environment we emphasize over at Forge College.
So what does victory actually look like? Well, it looks like a beautiful, successful terminal run. Your original mnemonic outputs an address ending in, let's say, 123. Your restored mnemonic outputs that exact same address. Pass. This is the absolute beauty of determinism, guys. Identical inputs plus the exact same derivation path must mathematically yield identical outputs every single time.
Now, your script shouldn't just spit out a generic pass. Take a look at the essential outputs here. You really want your script to visibly print the exact path used, the raw public key, and the final address. Why? Well, because printing all that raw material allows a human reviewer to fully audit both the engine and the exhaust, so to speak. It just takes all the guesswork completely out of the equation.
All right, let's move to Section 4, interpreting mismatches.
So say you run your script, and it throws this big, scary fail error. First thing, take a deep breath. Do not panic. When things don't match up, it's usually kind of like getting lost in a hotel, because you just assumed every building uses the exact same room numbering system. The most common culprit is simply that different wallet software uses different default paths. Your keys are totally fine. You're literally just knocking on the wrong digital door. So, the crucial point is to methodically check these three things. First off, check your path alignment. Are you at index 0 or index 1? Second, Check the network format. A single public key is going to look radically different if one side formats it as a legacy address and the other uses a modern Bech32 address. And third, look for a corrupted mnemonic. Even an invisible whitespace or a tiny typo will change the resulting seed entirely.
And that brings us to our final section, Section 5, the final artifact.
Okay, we've done the manual checks, we've mapped out the paths, built a script, and learned how to troubleshoot. Now we package this script into your final capstone deliverable. So what does done actually look like? Well, your artifact must be short, it has to be runnable locally, and it needs clear automated exit codes so a grader can easily read it. And crucially, it must include reproducible installation commands. That way anyone can safely reproduce your verification on a completely fresh machine.
Now, I cannot emphasize this next point enough. Never paste your mnemonic into a public environment. I mean this with absolute seriousness, guys. These verification scripts must have the most minimal attack surface possible. They must never, ever transmit your mnemonic secrets off your machine. Keep it offline and keep it minimal.
So I'll leave you with this provocative question to chew on. Will your custom verification script actually output all paths match when it matters most? Because honestly, that is the ultimate test of your secure wallet management strategy. Build the script, test the restoration, and secure that cryptographic certainty for yourself. Thanks so much for joining me for this explainer. To dive deeper into this and basically everything else Web3 related, visit us over at forge.college. Keep building, keep verifying, and I'll see you next time.